Luckily, Justice League gives me exactly what I need. While Flash is trying to outmaneuver a newly resurrected Superman, a dramatic moment reveals that Superman is keeping his gaze locked on the Flash as he moves. This tells us one very important detail, that the Flash is not moving faster than the speed of light in this scene. In fact, at this moment, Flash is moving slow enough that Superman, from a few feet away mind you, can keep a visual lock on him. You see, sight works when the eye takes in light that's been reflected off of another object. As a result, what you're seeing is always slightly behind what's actually there, as it takes time for the light to travel between the object and your eye, and then for your brain to process that image. So if you were to move faster than the speed of light, well, weird things would happen because relativity as we know it would start to break down, but one thing other people certainly wouldn't be able to do is accurately track your movements. Superman may be super, but even he can't speed up the rate at which light is traveling. And also, yeah, he may be tracking Flash using some other method, but it seems like it's clearly meant to be that Superman sees the Flash. So even though it's very possible that Barry Allen's able to travel faster than the speed of light, it's very possible that Superman is tracking the Flash's movements using some other method. For our purposes today, let's just assume that Barry is traveling slightly slower than the speed of light, allowing Superman to see him in the scene. Don't worry, it doesn't change the end results all that much. The speed of light is 671 million miles per hour. So let's put Barry slightly below that at 670 million miles per hour. Here's the problem. At speeds that high, Barry would be walking around with a fusion bomb going off on his chest. No joke, humans right now have a hard time achieving fusion because of a little wrinkle called the Coulomb barrier. For fusion to happen, particles have to get really close together, about 10 to the negative 15th meters close, in order for the strong nuclear force that exists in atoms to fuse the particles together. However, there's a problem with that. Just like magnets, two protons that are pushed together repel each other due to their mutual positive charge. This is the Coulomb barrier. Now, the barrier can be overcome by traveling really fast, speeds that, under most normal circumstances, are nearly impossible for humans to achieve. I'm talking 44,738,725 miles per hour levels of fast. But superheroes don't operate under normal circumstances. Like I said, Barry is traveling at 670 million miles per hour on a conservative estimate. That's nearly 15 times faster than what's needed to overcome Coulomb's barrier. And so fusion reactions would be happening over and over again in that dense cloud of molecules that's building up in front of him. And each of those reactions would correspond to a temperature of around 5 billion degrees. And that's not all. According to work done at the University of California, San Diego, these sorts of temperatures and energies would turn little bits of air molecules into plasma. Left alone, those small particles of plasma would explode to the size of football fields in 0.1 millisecond. So as he ran, Barry would be lighting off thousands of high-energy fusion reactions and giant plasma explosions wherever he went close to light speed. Which is why, in Justice League and the comics, it's so lucky that he has access to the Speed Force, which renders all of this a moot point. Remember, the Speed Force warps the physics of the air around him so he doesn't overheat and cause a plasma streak. And that would be the end, except for one man.